I forgot that we had a little bit more to talk about on this topic, and that is the difference between a molecular and an empirical formula. We discussed this back in chapter 5 when we were talking about naming compounds, and we said, oh, the difference is that in a molecular formula, I'm talking about covalent compounds, and I'm talking about the actual number of atoms in each of the molecules. The empirical formula is the lowest whole number ratio. So for instance, for acetylene, which is a covalent compound, its molecular formula is C2H2, but its empirical formula would be CH, because I can divide these by some common number and get down to a reduced set of subscripts of CH. Similarly, this benzene is C6H6. It also has an empirical formula of CH. So you can see that for these covalent compounds, the empirical formula does not give me a unique molecule. I have two different substances, different chemicals. One's C2H2, one's C6H6. They get the same empirical formula. And so they're not, empirical formulas are not quite as helpful, but it turns out from a percent composition, the best I can get is an empirical formula. I would have to have additional information to take that empirical formula and turn it into a molecular formula. For ionic compounds, there is no such thing as a molecular formula, because remember, they don't exist in molecules. They exist in just huge clumps of many ions all stuck together. The empirical formula is the best way to describe it. We always reduced our subscripts to the lowest whole number when we were writing our chemical formulas. So this is really a topic that we deal with covalent compounds, and hence the word molecular formula. So if you are given some additional information, like you are given information that you can come up with an empirical formula, so I'm given a percent composition maybe, or I'm told here's a sample and it has this many grams of this element and this element, and I can find the empirical formula, and the problem also tells me what the molar mass of the substance is, then I can determine the molecular formula. First, I would find the number of empirical formula units. So I would find out, well, what is the molar mass of one of my empirical formulas? I would add that up from the periodic table. And then I take the molar mass and I divide it by the mass of the empirical formula. That would be how many times I had reduced it to get from the molecular to the empirical formula. So now I just do the opposite. I take my empirical formula, every subscript in it gets multiplied by whatever this N turns out to be, and I would get a molecular formula. I'll go over one of these in class, but here's an example. So ethane diacid has a molar mass of 90.04 grams per mole. So you would have to be supplied with the molar mass, or else you can't do this problem. And a composition of, I have some percents for carbon, hydrogen, and oxygen. What is the molecular formula? So we would first start by getting an empirical formula and find out the mass of the empirical formula. I would take the molar mass, divide it by the empirical mass, determine how many number of units I have of this, and then I would scale up my empirical formula to get the molecular formula. We'll practice that one in class. It's a little bit trickier.